3.
And by my clock, it's 9 o'clock, but we'll give it a few seconds to see if anybody else does. We've got 3 now.
And my guess is there'll be a bunch of people that call in the next minutes.
They say we'll give them a minute or two to see if we can get anybody, and we'll give it a start.
Should have played the Printpack Corporate Engineering elevator music to start with.
Yeah, we're up to 3. It's time to go. I'd say let's do it.
Yep.
Okay. Good morning. Welcome to the first session of Classroom 3, or the first symposium. We've got the Printpack engineering team here, or a good portion of it, to talk to us about corporate engineering and engineering design practices. I'm going to turn it over to them, and if you have any questions, we've agreed that essentially put them in the Q&A section, and I will coordinate and get them to the presenters, and feel free to interrupt the group. We've decided that's the best way to handle it. So with that said, here we go.
Hi, welcome to the Printpack Corporate Engineering presentation here at the symposium. Today we are, there's 3 of us here. My name's Tim Sanford. We have Dan Short and Will Dolan. The topics we'll cover today are introductions of each of us, a little bit about our background. We'll talk some about how a manufacturing company uses energy to produce our sellable goods and what energy management means for a manufacturing company. Next, we'll cover the types of packaging we make and some of the processes we use to make that. Then we'll cover some project management tools that we use, and we'll kind of walk through a representative system that will demonstrate some of those tools, and you might be able to use some of those tools for your own projects. Then we're going to talk a little bit about life cycle management and sustainability of our flexible packaging, and then that'll kind of move into a conversation about moving away from non-recyclables. Just to introduce ourselves, my name's Tim Sanford. I'm the Manager of Facilities Improvement and Support. I'm a mechanical engineer from Georgia Tech. I've been with Printpack for 6.5 years, and my group provides a lot of mechanical engineering services, as well as energy management, some safety enhancements, what's called industrial engineering for our plants, as well as some maintenance standardization, so how we take care of the machines in our plants, how do we maintain our buildings and keep them in good operating condition. Dan, would you care to introduce yourself?
Good morning, I'm Dan Short. I'm the Manager of Electrical and Controls Engineering for Printpack. Our team focuses on designing power distribution systems, focus on energy hazards, safety of equipment, and we also develop original systems to support the plant's operations. And we'll hear about one of those systems today. And the other thing we do is manage obsolescence of equipment for the company. So that might include removing older components of a machine that are no longer available, be it the computer control systems, the motor control systems, or the human machine interfaces. And we also work on data collection and some of the technologies that are more in the digital realm in the modern manufacturing floor.
Will, would you like to introduce yourself?
Yeah, my name is Will Dowan. I am actually one of Dan's minions. I'm an electrical and controls engineer. I graduated mechanical engineering from Georgia Tech. My role in the group has been a bit of a split between project management of new assets coming in and retrofitting older assets. So Dan mentioned obsolescence, and as parts become unavailable and technology advances, the things you could buy 10 years ago, sometimes you can't buy anymore. And that leaves us having to basically replace the brains of some of our manufacturing equipment. I've been involved on a number of those projects.
All right. Thank you, Will and Dan. Moving on, we're gonna start with one of the fundamental things of manufacturing, and it takes energy to run those machines and to run the processes we have, and to also keep the lights on and keep the operators and different associates within our plants comfortable and safe. So energy is a big piece of that. And this is a pretty basic diagram of some of the inputs and outputs from manufacturing. And you know, with any manufacturing process, you put raw materials in and you get products out, and that's all this is showing. It's a little busy, but the main thing I wanted to show you was you have to put raw materials in as well as energy, and the energy makes all these processes run. And then you know, coming out the bottom, you get products and maybe co-products depending on what the item is that you're manufacturing. And then you also generate waste. So what I wanted to focus on today is this energy component. Just really quick, where do we get our energy from? This is a generic infographic about the U.S. in general. And a lot of our power comes from natural gas and coal. Natural gas has been a cheaper fuel source and a much cleaner fuel source. So this number has been growing in recent years, and the coal number has been shrinking. Nuclear has always been approximately 20% of the U.S. power mix. And of course, renewables are a big piece of what's growing, especially in like the Southwest, Texas, and some other areas. Renewables has really been growing. So, but the important thing to remember is just that there's a mix of power sources, both renewable and non-renewable, and both cleaner and not so clean. So, you know, coal and nuclear certainly have some negative aspects to it and some positive aspects. Natural gas has been a very economical fuel source in recent years. And then how does it get to our plants? This is just kind of a simplistic idea. There's power plants scattered all over the U.S. This could be coal, nuclear, it could be a solar farm, it could be a hydroelectric dam, it could even be some of the, you know, this could be the power plants out in the ocean that are generating power based upon wind turbines or even the wave motion. But the main thing is you got to get the power onto the grid. And by grid, I just mean the system of power lines, both transmission and distribution, that deliver the power to your facility. This could be your house. In this case, I just threw a picture of one of our plants in here, but it's basically the same process for whoever the end user is. So you generate the power at the power plant, and then it goes through a transformer to convert it to the voltage of the transmission lines. These transmission lines are the big, gigantic ones that you see running. You know, they're not everywhere, but they run down big, open. They almost look like a big, long field that's been where the trees have been cut away. And you'll see these transmission lines, very big cables, very high in the air to keep it away from people. Oftentimes, you don't see things built below it. It has a very large safety area around it because those power lines are very dangerous. These are very expensive. Power companies spend a lot of money maintaining these. But this is what carries the electricity between regions, between states, between cities. And then it goes to your substations. So you're probably used to seeing these maybe around your neighborhood or around the city or around the county where you live. These are these large fenced-off areas. Oftentimes it'll say the name of the company. Here in Georgia, you'll see them. They'll say like Georgia Power, Cobb EMC, Carroll EMC, some of these names you might see around town. And that is and then basically there's a bunch of switches and ways that they're directing that power to all the end users. But it's also stepping down the high voltage at the transmission lines down to the distribution. So distribution, these are the type of power lines that are essentially outside your house or outside buildings that you see on the streets. These are the ones that are up on the wood poles or maybe up on smaller metal poles. This is what's called distribution. This is really what takes it out to all the end users. And then either, like if you look outside your house or you look outside a building, up on a pole, a lot of times you'll see a circular transformer. That is the transformer that takes it from the distribution voltage and drops it down to the voltage you use inside your house, or in our case, a plant. This could be dropping it down to just a few thousand volts, or it could be dropping it down to, like for your house, it could be dropping it down to 208 or 120 volt power. And then our energy management focus as a company is to try to control costs and then achieve our sustainability goals. And those two things kind of go hand in hand. As we reduce energy, that's directly tied to the CO2 that's generated from producing that energy. So we have a financial incentive to reduce our costs. Obviously, if we can get energy for cheaper or use less energy, you know, that's less cost, and then our company can ultimately make more money. And then at the same time, that reduces our CO2 emissions from all that power being generated. So this is more of a goal, but our two areas of focus are reducing costs via procurement. This could be, you know, in several states, we can actually go buy power from different power sources, and those different power sources have different costs. So one activity we do as a company is to go and shop for the cheapest power we can get. Sometimes we're trying to also buy power that's renewable. We have two plants in Virginia, for example, that run entirely off renewable energy. Essentially, landfill gas is being used to generate power. So we use the procurement side to reduce our costs and also achieve some of those sustainability goals. And then we also have an efficiency, which is all about energy conservation projects. So you would automatically think of some of the common topics of swapping in LEDs for traditional lighting, or maybe putting in a more efficient air conditioning system. But on an industrial scale, while we do some of those things, some of the other stuff we do is we try to decrease the amount of power going into our manufacturing processes, or at least optimize how they run those machines so we're not constantly using electricity to heat up things or to have a whole system energized when we're not using that system. So energy conservation is our main engineering effort that we do to drive the sustainability goals and to reduce our costs. Any questions on energy? All right, we'll kind of move on to the next topic. This is just a really brief sample of some of the products we make. This is by no means all-encompassing, but it gives you a flavor of what we make. Most of our packaging we make is flexible packaging. So think all this stuff that does not really have a shape in and of itself. All these wrappers and pouches and bags. But then we also make some rigid packaging, which is still plastic. It's made using a thermoforming process. I'm going to walk you through the majority of our packaging, which is this flexible packaging. So packaging is made up of many layers to get the barrier properties we need, as well as the structure or strength we need, and as well as what material we need to present it. You know, a big piece of packaging is advertising. You know, you're walking down the grocery store aisle and your eye is immediately drawn to the colorful package, or maybe the package that looks, you know, more appealing, or maybe it's something new and they're trying to catch your eye. Or maybe you're just looking for that old faithful food that you like to eat. You want to be able to recognize it. So all the different layers essentially are to one of those ends. And I just we threw this up there. A lot of the barrier properties have to do with controlling the moisture content, reducing or increasing the amount of oxygen transmission, or preventing light from hitting it, because oftentimes light can degrade the food. So all these things are different types of barrier properties, and there's different combinations of materials that our product development group are experts in. Those barrier properties and those different materials layered in different combinations provide the properties of the packaging that you need. And then we use a number of different processes, and I know this is a lot of words out here, but essentially you can kind of break it down into 4 or 5 different areas. Blown film and cast film, these are simply extrusion processes where we make the film. So making large rolls of plastic sheet that's wound up. So there's 2 different processes we use for that. Then the printing is making those graphics that we talked about. It's putting that, you know, a picture of the product on the outside. It's putting the name, the logo, the nutritional information, ingredient lists, all that sort of stuff. We use 2 different processes for that. And then on top of that, we use lamination to build more properties into the structure. And so we're actually either gluing pieces of plastic together to get the right combination to have the barrier properties we need, or we're extruding, which is basically melting a sheet of plastic in between 2 other sheets, and it essentially welds it together. If you've ever done plastic welding, it's basically the same process, but instead it's in a sheet, and you're essentially dropping a new sheet of plastic that's molten in between 2 others and then essentially welding it together. And then slitting and roll handling. Slitting is when, you know, we make these rolls in very wide, think 65 inches, think 80 inches wide, these big rolls that weigh thousands and thousands of pounds. Well, our customers' machines are not built for those big, wide webs. They're built for much smaller webs that are actually the width of the final bag. And so we need to take that big roll and slit it down, literally just cut it down through a machine called a slitter. And then we need to handle those rolls to get them onto pallets. Additionally, some of those rolls we turn into bags. And I'll show you an example of that in a minute. So blown film is a process where basically little tiny resin beads go in a hopper, and there's lots of different plastic that gets mixed together. Essentially, it gets pushed through an extrusion process. It heats up the material so it becomes molten, and then it's pushed through a die, and the die basically gives it its shape. In this case, blown film is actually it's kind of I'll tell you to go YouTube it after the video because it's really, really interesting. In fact, it's probably my favorite process we do at Printpack. But it essentially extrudes that plastic into a circular, annular shape, and then we use air to essentially blow it up like a balloon. And then it's moving upwards, and then it goes through a frame and collapses. And then at that point, it's in what we call lay flat, which is just a big, wide web, and then we essentially wind it up as a roll of film. So this is how we go from plastic resin beads of different types, and we end up with a roll of film. The next process is, well, I don't have a slide for it, but cast film is a similar process, except we're not blowing it up. We're essentially extruding it out the end, and then it gets wound up as a roll of film. Again, you can find a lot of YouTube videos that illustrate this better. A Flexo printing press, this is the type of press we use most of the time. It essentially, you take those big rolls of film that we've made, and you can't really see in this picture too well, but that roll sits over here, and then there's a series of rollers that allow that film to be brought into this printing section. Each one of these is a printing deck, and it's applying a color. And so each station is applying one color. You can have up to 10 colors. And there are tiny little modular dryers in between each of those colors that essentially dries that color before going to the next station. After the final color, behind this shroud, there's a very large dryer that we call an overhead dryer. And hold on a second, I'm going to use an annotation tool here. Bear with me for 1 second. So you've got a dryer up in this area that essentially dries the whole thing and locks everything in. And then it gets wound up on another roll on the back end. So this is our most common printing press. The advantages of this printing press is it is very flexible. It's very easy. So for each one of those colors, you have to have a set of printing plates so you can apply the graphics. And these have much simpler, it's very easy to make these plates versus other types of printing. Here's an example of the inside of one of those printing stations. This is a 4-color press. You can count 1, 2, 3, 4. And, you know, each one of these is applying a color. And really the technical difference, what makes it flexographic, is the way that this process happens. And again, it allows us to use a much simpler way of you know, some types of printing presses, you have to use a metal cylinder, essentially, to imprint the artwork onto the web. These use a polymer process that it makes it much simpler and easier to swap out graphics. So this is much more flexible. Here's another example, just another interior look at one of those printing stations. This is called a Rotogravure Printing Press. It looks quite different, but really the goal is the same thing. Instead of having all those printing stations in a big circle, each one of these is a printing station. So each one of these is a color. And it's using a different combination. This one actually uses metal cylinders to generate the artwork or to imprint the artwork onto or transfer the ink onto the web. But again, you've got an unwind and a rewind, and you put that big roll of film on one end. It goes through each of the printing stations. It applies a color, and then on the back end, it's wound back up. This type of printing press typically is associated with finer detail. Maybe you consider sort of like a higher resolution picture. Sometimes it's considered to be a higher level of printing, although both have become much more comparable in recent years. Here's an example of what's going on. It kind of illustrates the difference of what's going on inside the Rotogravure printing station. And if you notice, this printing cylinder is metal. So all the artwork, which it's trying to show right here, is essentially engraved through an engraving process. So this, you can imagine, this is a much more expensive process to get new artwork made. The next is extrusion lamination. This is the one where we're talking about putting different layers of film together to get the different barrier properties or the different material properties. You've got essentially two different films. You've got a number 1 and a number 2, and sometimes we coat the film before it is essentially welded together. But regardless of what's going on, the main business section of this is right here, and you've got one roll of film going in. You've got another roll of film coming in, and you're essentially making a layer of film in between these two and welding it together. So right here, this would be an extrusion process with that molten plastic coming down. We call this the curtain. And it's essentially making another layer of film between these two layers, and then you're welding it together because it's hot molten, and then you're locking it in. This is called a cooling roll. It basically cools it and converts it all back to solid material. And then it's going to get wound back up. There's a great picture of what's going on. You got one roll of film, and then right in this area right here. Sorry, you can't see that color very well. Let's see. You can't see any of these colors very well, but right here in the middle is that. Right in the middle is that layer of molten plastic going in between the two layers of film, and then you see the big cooling drum. You see the big cooling drum right here. That's cooling that and locking that all those three materials together. Moving on, the next type. We have several different types of adhesive lamination, but just think, instead of welding it together, I'm gluing it together. So I'm just like a printing press applies ink. This type of coating station applies a glue, and those glues can be different types of glues. Some of them are kind of like a two-part epoxy, like you might glue something together when you're repairing some plastic or something like that. Others are more like others are water-based or potentially solvent-based. It just depends on the application and what our product development engineers have determined works best for that material. But the concept is the same. You got one roll of film, you got another roll of film, and then you're using some sort of coating station, which is very similar to a printing station, to apply that glue, and then it cures, and then it gets wound up. Sometimes that curing involves a dryer, just like on the printing press. Sometimes it cures on its own via the chemical reaction that's happening, such as that is very similar to what you see like in two-part epoxy. Here's an example. This is an example of a solventless laminator. This is using that two-part epoxy. Basically, you got an unwind and a rewind over here, and over here's that coating station that we talked about. It has no dryer. This is all open up here, and that's because it's using a chemical reaction to cure rather than drying off water or solvent. And then this is a slitter. So on this picture, you can't really see the back end, but on the other end is a giant roll that's probably about as wide as that shaft right there. And then essentially what we're doing is cutting it down to, so it'll be as wide as these 3 rolls put together. And we're taking that big master roll, which is, we like the big master roll because that's easy to move around our factory. But our customers can't use that big master roll. They need to use these small rolls because on their bag making line or on their pouch making line or on the filling line, they just need a small roll. They can't handle those big rolls. So this is called a slitter, and literally it's got a bank of knives back in the back of this machine that take that big wide roll and cut it down to these smaller rolls. And it's very here the name of the game is all about controlling those rolls of material. This machine is a very fast machine compared to all the other machines you've seen. The whole idea is to have very tight control loops that can maintain and build these nice rolls. As these rolls get narrower, they get a little bit harder to control. And so we want to build very nice rolls with very parallel layers as it winds up. And so this is an important process. There's a lot of controls that may allow this process to run very fast and very accurately. This picture is a little grainy. I'll move on to the next picture. But essentially, we take those rolls and we need to get them onto pallets because pallets are how we ship things on trucks. So if you look back in the background, you can see those slitters. There's basically a series of conveyors and robots that are handling these rolls. Sometimes we bag these rolls in order to essentially protect them while they're in shipment. And then we're using additional robots to put them on pallets. Sometimes in other types of plants where automation isn't as important, we're using people to do this with ergonomic enhancements to keep them safe. But this is a big area of automation for Printpack and for the industry is, handling all these rolls. You can imagine if a person was doing this, it'd be very time consuming. And then here's just an example of a bag machine. So this is an area where we actually make the bags. Sometimes our customer makes the bags. It just depends on what their process is for putting their product into the packaging. So in this case, this machine, there's one of those big wide rolls of film that's made in another part of the factory. It basically goes through a series of manipulation to get it into a certain orientation. And then we are essentially putting different holes and the different features into it. And then we are cutting and sealing that bag within this station to come out with a series of smaller bags. These types of bags can be used for anything from primarily bread bags and other bakery type products are the primary application for this type of bag. But there's a whole series of different types of bag machines that we run and operate to make different types of bags. And oftentimes they look very different than this. It could be a large pet food bag. It could be a bag that's used for potentially toilet paper or paper towels or other types of large products. So I was just showing you one example of a bag machine where we're taking that roll of film and turning it into the bag that you see in the grocery store, essentially. And now I'll hand it off to Will Dolan to discuss project management.
All right, before we get started, anything that Tim covered regarding our processes and our manufactured goods? Q&A looks empty, so I'm gonna get going. All right, so I'm going to cover project management a bit, kind of how it relates to Printpack, and I have in parentheses in brief down here for a very good reason. And this topic is massive. There are, graduate level university courses on project management. People can get degrees in project management. it is a very large field. So what I'm going to cover is going to be pretty quick, but I welcome any questions. If you have anything, go ahead and throw it in the Q&A, and I'll pause as we go through it. To kick things off, I want to cover just 4 definitions, and I know this is kind of word soup on the slides here. But a project is a temporary endeavor undertaken to create a unique product, service, or result. So this is some kind of task. You can think of each of your robots as a project, right? Because every year the game changes. So every year you have to create a new unique product. Project management is the application of knowledge, skills, tools, and techniques to meet the project requirements. So project management is kind of the tool case of how we're going to handle the tasks, how we're going to divvy up the work, and how we're going to track our progress to make sure that we get to the end result that we need in the time that we need and within the budget that we have. So the project manager, most projects have, at least in the engineering world, a single project manager. And this is the person who is responsible for the project management efforts. So these are things like tracking the budget, tracking the schedule, making sure all aspects of the project are covered. They're typically not the person doing the actual work. So your project manager is tracking everything to make sure everything is getting done and looking for gaps. But your individual contributors, the actual engineers, or other workers, accountants, product developments, sales and marketing, they may be the ones that are actively doing the individual tasks. The scope is a pretty important concept. The scope is, as defined, the features and functions of a product, or the scope of work needed to finish a project. And this is basically anything that is going to be covered by the project. So we're going to go through an example a little bit later of a smaller engineering project that we had. And this project has a defined scope, because if we don't define the scope, then anything and everything could be considered part of the project, and you'd never be able to actually finish anything. So project management typically happens in 5 phases, with 3 and 4 kind of happening concurrently. There is some amount of conception and initiation. This is where the original need and idea for the projects are formulated. So somebody comes up with a business need, somebody else comes up with a rough kind of back of the napkin sketch of what we can do to meet this need. This gets taken up to a board of directors or some governing body inside a company, and they say, hey, we think we can address this need by doing this. And they give it the thumbs up or the thumbs down, and what comes out of that is a project charter. The project charter is basically the document that creates the actual project. This is typically accompanied by some guarantee from the financing group of the company that a certain amount of funds are going to be available, from different operation sections saying certain numbers of people are going to be assigned to the project. And so the resources are allotted. You get into project definition and planning, and here you can see scope, again, is the first thing that's listed there. And you see some other tools that come out of this, like there's a budget, of course. There's what's called a work breakdown schedule, Gantt charts, communication plans, risk management. We're going to talk about a couple of those, but not all of them. And this is where a very large amount of the project time is spent. So it is pretty common to see upwards of 30% of the time of a project spent in definition and planning. And the reason we do that is if you operate in a reactionary manner, meaning you just kind of dive into the project and start doing stuff, and if it doesn't work, you change it and do something else, that's great. It's a great way to experiment. It's a great way to learn things, but it can take a long time and it can get very expensive. So we try to plan ahead as much as we can. launch or execution and performance and control, these two kind of happen at the same time. So execution is you're doing the work. You're tracking the status. You're looking at KPIs, which are key performance indicators, and these are basically little metrics to track how well the project work is being accomplished. This could be things like we've completed 7 sub-features in the last month. Our target was 6 sub-features, so we're a little ahead of schedule. You can get over into performance control too, which kind of blurs the lines with KPIs a little bit. This is where you're checking for quality, you're watching your cost, you're looking at the performance of individual contributors and possibly vendors and contractors that you've hired to help with the project. And through performance and control, you're also checking your project management tools and practices, and you're kind of watching for ways that you can make them better, either for the current project that you're on or maybe just for the company in general. And at the end, we hit project closure. All projects must end. And one of the most valuable things in here, or the two most valuable things, are the record keeping and what we call a post-mortem or a lessons learned discussion. And that's where you start talking about things that went well in the project and things that didn't go well. What are things that we want to repeat in the future on the next project, and then what are things that we want to avoid? And then record keeping is critical too. And we'll get into that, into why a little bit in the planning section. So this is the actual project management flow chart for engineering within Printpack. And you can kind of see off to the left, that's the full chart, and I've kind of blocked off in red the section that's zoomed in. So this is going to pretty much follow the 5 phases that I showed you earlier. Somebody comes up with a business need. This business need goes into a proposed solution. This proposed solution will end up resulting in a project charter, and we'll have some engineering assets assigned to it from there. We may then, depending on what the scope of the project is, we may have to define a more rigid specification. We may have to bring in other departments, like we might bring in a mechanical engineering group along with the electrical engineering group. Maybe we need some facilities engineering. So depending on what we find in the proposed solution, the specification may or may not be, a large effort. From there, we start requesting some initial quotes, right? Everything costs money, and we want to get the best value for our dollar, so we shop around. We don't want to just keep going to the same people over and over again because we don't know if we're getting the best deal. We also want to bring in new technology and different solutions when appropriate, so that we stay ahead of industry trends. We're adopting new technology that helps us prevent obsolescence issues, and there's efficiency gains too with new technology, right? The technology doesn't just develop because people want to develop it. There's a reason, there's a need behind it. So from here, our project management kind of splits. And off of the right, you can see the construction path. We're not really going to talk about that. That's like building construction. If we're going to a green field, which is just a big plot of land, and we're going to build a factory there, there can be a lot of effort that goes into the construction path. For the most part, where we spend our time in engineering is on this, and this is the equipment path. So you can see up here we have requests for quotes, and now we go into vendor negotiation and selection, right? So we've got a whole bunch of prices and information on what our different equipment providers can make. And then down here, we actually start fine-tuning into what it is we want. Maybe there are some features on those machines that we definitely do want. Maybe there are some that we think we're just going to be throwing money out the window, and it's not going to really give us the payback that we want. So we very carefully go through vendor negotiation and selection. We get our best price, and most importantly, we make sure that the equipment that we're purchasing is going to do what we need it to do. Here you see what we call a CE request and approvals and order placed. So CE for us is capital expenditure, this is basically the chunk of cash that that finance is setting aside for us to do our project. We go through design review, which is basically we bring in the rest of the engineering team and make sure what we're purchasing is going to be what we need it to be. And then there's the obvious steps of, all right, we're going to order the machine. The machine is going to be tested at the machine builder's facility. Oftentimes for us, this is something in Italy. So we have the burden of having to go to Italy and play with machines. It's a tough life, but somebody's got to live it. Machine gets shipped out to us. The machine comes in and gets installed. And parallel to this, we're of course doing site prep on the factory side to make sure that the machine has somewhere to sit. And we start initial training of our operators and facilities and what they're going to need to be able to run the machine efficiently and safely. And at the end of that, we have what we call the commissioning effort, and this is really where the machine comes to life in our facility. Primary in there is the safety inspection. We, of course, want to make sure that whatever we're doing is safe to work on. And then you can see we kind of loop back and we iterate through these steps a couple different times to make sure that in the end, the machine is what we want. And then the last two are effectively documentation efforts. So we talked about this a bit earlier, so I'm going to breeze through this slide pretty quickly, right? The idea of initiation is somebody's identified a need, you bring that need forward, you start outlining the basics of what you would have to do to address the need, and this leads into a project charter, and the project is officially created. So one of the projects that we're going to kind of talk about a little bit as we go through this will be something that we call a solvent delivery system. And as Tim told you earlier, we have a bunch of printing machines. Well, these printing machines typically require some kind of solvent to be able to treat the inks the way they need to be treated to print properly and to clean up the machine in between jobs if you have to change a color. And it's no fun to carry buckets of these through the facility, so we want a system that's going to be able to deliver them to our production assets efficiently and safely. So that's kind of the proposed solution, right? So then we get into project planning, and here we have an example of a Gantt chart, and this is an extremely powerful tool for project management. This is effectively a schedule with dependencies. So you can see kind of the dependencies by these vertical lines going from one task to the next. You'll note that over on the left side, we have all the tasks. We have how long we expect the task to take. We have the date that we plan to start the task. And then based on the duration and the start date, the software will automatically pull up the finish date, and we select the predecessor. So what this means is, for this quotes example, I can't start getting quotes until I finish what's on row number 2, which is the design. That makes perfect sense. How am I going to get a quote on something before I know what I'm trying to get a quote for? So you'll see that over here by this vertical line that drops down and starts into the quoting process. You'll also notice some that have a red box around it. This is something called a critical path. What we're identifying here is basically based on this schedule and based on our dependencies, there are certain tasks that if any of them take any longer than what we have planned, the duration of the project gets extended. So if you look at order for this procurement line, this is not on the critical path. So if this were to take another week, I'm not actually going to extend the duration of my project at all. But if the electrical design on this one were to extend any further, it's going to push out all of the following tasks, and that means my entire project is going to get longer. Now, this Gantt chart was built using Smartsheets. There are lots of different tools that can build these. There's Smartsheets, there's MS Project, there's even some free ones online that you can get your hands on. And a lot of these probably have educational licenses too, so it'll be easy to get your hands on to use it for your teams. Project planning also includes clear roles and responsibilities. And one of the primary things here is confirm that all necessary responsibilities are assigned. So you want to go through everything that's going to need to be done on the project and make sure somebody's assigned to do it all. Communication is another critical part of planning. Who needs information? What information do they need? When do they need this information? These could be things like recurring meetings, or they could be emails and Slack updates. It is important to document the project plan. This plan can be modified, but you want to make sure that there is a documented version of it somewhere just to keep everybody on the same page, so when you have people acting independently, they're still acting in line with the direction of the project. And you, of course, want to check in with stakeholders, which is anyone that has an interest in the success of the project, and project participants, anyone working on the project, just periodically to make sure that there's no gaps, that nothing got missed. So just a couple quick examples of our design work. This is a section from what we call a PNID drawing, which is piping and instrumentation drawing, or process and instrumentation drawing, depending on who you talk to. And this is a document that's basically showing, we have a connection to a solvent line here. We have all the different little bits and pieces that we need to be able to safely dispense solvent, either by a manual nozzle or direct to a production asset. And you can see all the notes that go along with these, right? So there's a tremendous amount of detail that you have to go to on corporate engineering projects. Electrical design is somewhat similar. This slide actually shows two examples of electrical design work. You have what we call a panel layout on the left. So this is roughly where components will be in the actual panel. And this is a true to dimension physical layout of the electrical control panel. And what I have circled in red is this section here, and this shows you what we call the wiring diagram. So this is how we actually draw the electrical connections for all these different devices. So all of this design work has to be accounted for in project planning and then be done in execution. And then, of course, we talked a little bit about execution. That's where the actual work is done. You're going to procure parts. You're going to hire contractors. You're going to install and commission, monitor and control. This is where you're tracking against your budget. You're tracking against your schedule. One of the things that we didn't really talk about on the Gantt chart is it is possible to, on most of these Gantt charts, have a second line underneath each of these that's tracking the actual duration of any of these steps. So you have a nice visual representation of how well you are following your project plan. At the end of this, of course, is closing. And one of the things that's critical here is discuss and document lessons learned. So why do we have such a focus on documentation? And that's because when you come to create one of these Gantt charts, how do you know it's going to take 5 days? Well, if it's your first time doing it, you probably don't. But if it's your 10th time doing it, then you theoretically have 10 projects that you can look back on and think, okay, how long did it take me to procure these parts? How long did it take me to establish the quotes? If I have all of this information documented, then my next project plan is going to be much more accurate. And just some quick resources you can use. Project Management Institute. This is an organization for professional certification in project management. One tool that we use a lot is Smartsheets. We use this for Gantt charts. They probably have educational licenses. You can find them at www.smartsheets.com. MS Project is another great one. And then, of course, do a Google search. There is a lot of project management information available. And that is it for me. That is project management in about as small of a nutshell as I can get. So if there are any questions, I'm going to pass it on to Dan to talk about sustainability. All right, Dan, you're up.
Let's go ahead and advance the slide. All right, well, we talked a lot about manufacturing processes, and I wanted to introduce the other concerns about being a manufacturer and a citizen of the economy, and that is looking at the costs, overall costs, and the life cycle of any product. We may come back and talk about Printpack products. Getting distracted here. sorry. So let's say we're talking about putting assets in, and then as we ship materials, we're essentially putting things on trucks, on pallets. They're going to distribution warehouses, ending up at a retailer, and then finally, after a consumer comes and buys those materials or those products in their home, and at the end of their useful life, let's say it's a disposable item, or you've eaten your apple, you got to get rid of the apple core, you discarded it, and that is considered the end of life. And I'm going to be talking mostly about end of life concerns. So all through this process, energy is consumed, and that means that carbon emissions are also associated. So the carbon emissions follow the life cycle throughout. 40% of the carbon emissions and waste are produced at the end customer use level. And the reason for that is because of the amount of waste that we as consumers in the US generate. We may just discard a piece of food. We may discard a plastic small tool. Maybe it's one of those fancy toothpicks with a piece of floss strung between it, where you use it once and done, and into the bin it goes. So go ahead and advance, please. Tim? Okay. So one of the big problems that we face in our world is the issue of food waste versus our population growth. So some statistics are estimating our population to grow by 33% by 2050, which is only now 30 years away. 30% of the world's food goes to waste each year. And the largest, like I mentioned before, the largest food wastes occur at the end consumer. The 44% of viable food product ends up in landfills. And the need, right, the need for a successful population to grow is to minimize that food waste. Go ahead. So, for example, we'll talk about, generating food. So beef or chicken or dairy takes a tremendous amount of energy from the world. The carbon footprint is significant to make these items. So the worst thing you can do is to, find a flaw in the product itself and then discard of it. So one of the things that we are looking at as a community is building up a circular economy. So this is a concept that's been promoted heavily by Ellen MacArthur, and Ellen MacArthur was, I guess she made her name by being the first woman, I think, to sail around solo the globe, after which she used that platform to promote a green environmental agenda. So in this economy, in the circular economy, there is no such thing as material waste. So you can see on the right-hand side, we're looking at the materials for packaging, for example, coming back into the parts manufacturer. You use some of my arrow tools. There's recycling, there's reuse, redistribution. You can maintain or prolong. A big effort is in collection. And then also on the organic side, after the consumer uses something, there's extraction of materials or usable goods. There's the biogas we mentioned earlier. We have a couple plants that are working on biogas energy sources, and essentially regenerating the biosphere, and then farming and collection of those organics, and they go back into the supply chain. So this is kind of a visionary model. Certainly, it's not something we've achieved yet. Go ahead to the next slide. So this is more of a realistic model of what and how our economy operates. So I'll go ahead and start with sourcing. So if you look at sourcing, you're adding raw materials, and it is you're adding raw materials, you're doing your manufacturing processes, and then it's hitting distribution, end use, and then recovery. So the recovery is really where we're focusing on trying to close this circle. So we could get to circular if we get all the way back here. But what's actually happening is there are elements of our economy that are going back into composting, energy recovery, so or landfill, litter, and other, I can't quite read that, regeneration. Okay, slide. Okay, so there's two ideas. So the circular economy is more of like an ideal model, and then there's also the sustainable materials management, which is really dealing with today's realities. So, so design focus as engineers and parts of this community is to recover, reuse, refurbish, and then also for sustainable materials management, you're trying to create more efficiencies in your system, utilize the right materials that have the least impact on the environment, and design in materials that can be recycled or composted. Go ahead to the next. So Printpack's perspective, we have been lining up with the idea of corporate social responsibility. So that's continuing a commitment by business to behave ethically and then to contribute to economic development while improving the quality of life of our workforce and their families, as well as the local community and the society at large. So our model revolves around people, plants, products, and partnerships. So let's go to the next slide. I'm running short of time, so bear with me. We'll skip past the people for now and move into plants and processes, since that's more where engineering is involved. So our initiatives are to reduce waste to landfill, reduce the amount of energy, reduce our greenhouse gas emissions, of course, reduce hazardous waste, and reduce our water usage while increasing recycling within our plants. So if we had a waste stream within our plant, we want to keep that waste and build it back in. So if we had to take trim off of a sheet of plastic to get it to the right dimension, we want to take that sheet and put it back into the extrusion process. Let's jump to products. So some of the things that we can do is simple down gauging to reduce the material usage, designing with the environment in mind. So we may take a piece of plastic sheet and simply make it thinner. A better way to do that would be to move towards redesigning the product so that it is simply utilizing less material overall by its form, or also, that applies to the packaging for that product. And also, we can look at using renewable sources of raw materials, such as like a polyethylene that's based on sugar cane. So we're not taking oil out of the ground. Customer end use, I don't have enough time to go through this, I apologize. Let's talk about plastics identification. So we're all aware of the little recycle symbols, but we're probably not up to speed with what all of those mean in terms of recyclability, reusability, or repurposement. So what we've come up with as an industry are some new tools, which is on the next slide. There's a group called How to Recycle, which essentially, instead of just saying what the material is, it says, what are we going to do with the material? So this provides instructions on how to dispose of the newer recyclable goods. Because right now there's a mix of these goods on the market, and you need to be able to quickly distinguish which ones can be put back into the recycle chain. So there's a couple examples. We already talked about those products and these rigid products that are also recyclable. And the final thing is forming partnerships. So essentially, this is not like a governmental level, but a voluntary set of organizations and people and companies that get together to share ideas and listen to the market. So it involves people like product development engineers, our suppliers, raw materials providers, recyclers, and then of course the voice of our customers and marketing. This is really the way that the industry shifts and guides the future development and helps in planning for the future. It also provides a platform to showcase our progress towards sustainable methodologies. So, for instance, one of these groups is like a voluntary carbon footprint reporting program, and we also like capture the amount of like a percentage of waste estimate, and it finances some reports. I think we're at 10:01. So there's clearly some questions, some challenges rather. There's the current realities of our infrastructure. We may not have enough recycling centers in the United States. We have to sometimes sometimes have to make choices for materials that are more cost effective to maintain our viability in the market. There's technical gaps. There aren't always solutions developed yet for recyclable or renewable packaging or products. The availability of those renewable products of the materials that go into those renewables, that of its structure needs to grow with the production demand. So for example, if I need to have 20 billion tons of polyethylene, but the polyethylene manufacturers can only do 10 billion, we're kind of behind.
I really hate to cut this off, but we've reached the end of the time, and I've got to get set up for the next session here. I want to thank the Printpack group for an excellent overview of how project management and project definition, project management, and how they get executed in the real world. We'll take a minute to get any quick questions, but otherwise I'm going to call this one to an end so we can set up for the next session. The next group in this classroom is going to be surviving an FTC robot inspection. So if that's of interest to you, please stick around. You'll have to join the next session again. Anybody got a question?
We've got one about will the PowerPoint be available later? I'm not sure if the raw presentation materials are going to be made available through the symposium, but we can work with Georgia First to make it happen.
The entire presentation is being recorded and will be made available, and I suspect we can arrange to have the raw PowerPoints made available also. Anything else? I want to thank everybody for joining us. And again, I want to thank the Printpack group for a very pleasant and enjoyable presentation. I learned some things. I don't come from a manufacturing background, but I do come from a controls background, so seeing some of the machines and descriptions of how they work was pretty entertaining to me. Again, thank you, gentlemen, and thank the group. I'm going to call it quits on this one.
Thanks, Jeff.
Certainly.
Thanks, everyone. Enjoy the rest of your symposium.
Okay, great. I forgot how to stop this. There we go.